Right, hello. Today I thought I'd have a look at a pyramid question. These often come up in GCSE, and we'll have a look at an old GCSE question on a pyramid, and then we'll have a look at some follow-up ideas of what they might be able to do. So, right, in this question it says, here's the pyramid. It has a square base, A, B, C, D. AB is 5 meters. Vertex T is 12 meters vertically above the midpoint of AC. Calculate the size of angle TAC. So what we do, first thing is, again, a diagram, start putting anything on there we know. So AB is 5 meters, so I can write 5 just there. The next thing is, I'm going to look up here, and it says the pyramid is a square base. Okay, if it's a square base, all the sides are the same length. So they're all 5 meters. Right, the vertex T is 12 meters vertically above the midpoint of AC. So I'm going to draw the line AC if I can. And I'm going to draw a line down from T. And that will meet at a right angle. And what we have is that is 12 meters high. So it says calculate the angle, size of the angle TAC. Well, TAC is going to give me that angle there. So typically on these sort of questions, you've got to do something before you can do something else. So the first thing we're going to look at is think, well, if I need that angle, I'm going to use trigonometry. If I'm using trigonometry, I need to know two sides of a triangle. I've only got one. I've got the height of 12, but these fives are all about the base of the pyramid. They're not to do with anything on that particular triangle there. So I'm going to just draw a little bit of a line. There's AC, and that's the diagonal of the square. So one half of the square is going to look like that, 5 and 5, and that would be at a right angle. So looking at that, I can use Pythagoras to find out the length of AC. So Pythagoras is going to, I'm going to call that x, and we'll have x squared equals 5 squared plus 5 squared. So x squared is going to equal, well, it's 25 plus 25, that's going to be 50. So x squared equals 50. So x equals the square root of 50. Now, I could work that out. It's going to be just over 7 because square root of 49 is 7. So square root of 50 is going to be just over 7. But I can leave that there because I'm going to use that later on. That's not the answer I'm asked to give, and I'm going to work it out. But I can use that as it is. So the square root of 50 is the whole way across. Yeah, that's the whole way across from A to C. But we only need halfway across. Yeah. So if I draw another triangle, and this is the triangle that we're actually trying to work from. It's 12 high, and we're trying to work out that bit there. The size of that angle there. If we put on what it is, it's T. That's A. And C is actually there. So we're trying to work out the angle TAC. This length here is going to be root 50 over 2. Half of root 50. Okay, so that's root 50 over 2. So we've got two sides of the triangle now. If we think of it, we've got the opposite side. we've got the adjacent side. So if I wanted to work out the hypotenuse, I could use Pythagoras and work out the hypotenuse, but that's not what we're asked. We're asked to find the angle. So the angle is the opposite and the adjacent, that's got to be tan. So if we go for tan of theta equals opposite over adjacent, so in this case it equals 12 divided by root 50 over 2. So it's 12 divided by root 50 over 2. And we can put that straight into the calculator if we want. And it would work it out. If you want, just to make that a little bit easier, it's 12 over root 50 over 2. We could actually bring the 2 up to the top. And it's going to be 2 times 12. So that's 24 over root 50. So we've got to find the inverse of the tan, and the inverse of the tan, we can shove that in there, so tan to the minus 1 of 24 over root 50, so theta is going to equal 73.6 degrees. Okay, so theta equals 73.6 degrees. And that's the question answered. That's all it is. Now, it's typical of these sort of questions for pyramids. They get you to do one thing, they get you to do another thing, and they get you to use 2 different parts of maths. So the first one we've used Pythagoras, the second one we've used our trigonometry or SOHCAHTOA, and it's very typical to use that in a pyramid. Use one to find something, and then use the other to find the answer that they're after. Let's have a look at where else they could have gone. We could have a look at the volume of the pyramid. Now the volume is going to be the volume of a pyramid, V equals 1/3 times the area of the base times the height, times the vertical height. So in this case, it's a very straightforward one. So it's 1/3 times the area of the base. Well, that's 5 times 5. And times the height, which is 12. And we can even do that in our heads, because 1/3 of 12 is 4. 5 times 5 is 25. 25 times 4 is 100. So it will be 100, and it's meters cubed. So volume, fairly straightforward from that. If they are going to ask you to use volume, they would have probably got you to work out something a little bit harder in order to do it. They might have asked you to do something to find the vertical height and then find the volume. Let's have a look at what else we could do. Surface area. Now, surface area, we need to look at all the sides. Now, all the sides are here. We've got 4 triangles, which are actually the same, plus we've got the base. So the surface area, I'm going to call it SA, and that will equal, or the area of the base, yeah, or I'll just put base plus 4 times the triangles. Yeah, we've got to find the area of each triangle. And the base is dead easy. The base is just 5 times 5, which is 25. And then we're going to have to add 4 times something. Now, need to work this out. So in order to work this out, because I don't know what the area of the triangle is, but the triangle, if I look at it, if we want to get the area of the triangle, is going to be a half times base times the height. We all know that. Half times the base, well, it's half times 5, but I need the height. I need this sloping height. I need from there down to there. Okay, so from T down to the midpoint of AD. Yeah, and that's only way to do that is again through a little bit of Pythagoras. If I draw the triangle, yeah, the triangle, the height is 12. The bit going across, because we're only going to need to come across halfway, is actually 2.5. Yeah, it's all the way along, it would be 5. Yeah, so 2.5 and 12. If we use Pythagoras, then we can use find the length of the sloping side there. So I'm going to call that S. So S squared equals 12 squared plus 2.5 squared. So S, if we work that all out, yeah, don't forget to put them in together. So 12 squared is 144 plus 2.5 squared will be 6.25. So that's 150.25. We're then going to square root it. S itself is going to equal 12.258. Okay, so we've got the length of S, so we can put that into our triangle. So that's going to be a half times 2.5, isn't it? Because it's only 2.5 along. No, it's 5. Half. Sorry, the triangle is 5. Half times 5 times 12.258. Okay, so the area of the triangle is actually 30.644. Okay, so I can go back up to the top here. I can throw my 30.644 in there. And if I multiply all that out, 4 times 30.6.4 plus the 25, I end up with the surface area is 147.6. And that will be square meters. Now that's working out the surface area, and surface area is always an awkward one. Any sort of 3D shape to do the surface area, they've usually got to find a few. This wasn't too bad because you've got 4 triangles all the same, and that's quite an easy one to do in the end. All right, just a couple of things. Point to note: it's when we first look at this question, the first thing I notice is it's 5 meters and 12 meters. Now 5, 12, there's a 5, 12, 13 triangle, but it's not used. It's not used because it doesn't fit anywhere on this. So they've used the numbers 5 and 12, and you think it's going to be the 5, 12, 13 triangle for Pythagoras, and it's not. So it's just a point to make sure you notice that. Okay. Just like to say thank you very much for watching it. If you want to email me about anything, my email address is there. And that's it. Thank you very much.